Hello everybody, myself Jyoti and this is the fifth lecture on nuclear energy. It is about nuclear chain reaction. What is a chain reaction basically? Now, in nuclear fission, an incoming neutron causes a heavy nucleus to split into two smaller medium mass nuclei, which are called as the fission fragments. Like we have a uranium 235 nucleus, suppose, then it breaks into two masses which are comparable, which are having comparable masses. Suppose uranium 235, it breaks into barium and krypton, then the barium and krypton, they are called as fission fragments. Now these fission fragments which are formed during nuclear fission reaction, they are radioactive in nature and they are rich in neutron content. They have larger number of neutrons and they undergo several stages of negative beta decay until stable nuclei are formed. This we have already studied when we have studied asymmetrical fission. In asymmetrical fission, we have considered one nuclear chain reaction, and then we have also discussed about the beta activity of fission fragments, barium and krypton. Some along with the beta particles which are emitted during nuclear fission reaction, some neutrons are always liberated in the fission process, and these neutrons induce fissions in other nuclei which then produce more neutrons, some out which are induce still more fissioning. Like I have a parent nucleus, suppose X, it captures a neutron N, then it produces fission fragments X1, X2. Along with that, approximately 3 neutrons are emitted. If not 3, at least 1, 2, or 3. Mostly 3 neutrons are emitted in a nuclear fission reaction and large amount of energy is liberated. Now, these 3 neutrons which are formed, they will be captured by another uranium 235 or another heavy nucleus, and again fission fragments will be formed and 3 neutrons will be emitted. Again, those 3 neutrons which are formed, they will react with another uranium 235 nucleus, again fission fragments and 3 neutrons will be formed. So this is a chain of reaction which is happening. So at least what is the condition for a chain reaction to go ahead or to move forward? At least one neutron should be emitted, and that neutron should be available for that neutron should be captured by uranium, another uranium 235 nucleus, so that it will again show nuclear fission reaction, fission fragments will be formed, and again neutrons will be emitted. So this kind of a reaction, it is called as a chain reaction. Now every fission liberates a large amount of energy, and therefore when we consider a chain reaction, large amount of energy is produced in a very short time interval, because we know that during one nuclear fission of a one uranium 235 atom, we get 200 MeV of energy approximately, and then 3 neutrons are also emitted. Now these 3 neutrons are going to react with another uranium 235 nucleus, again 3 neutrons will be emitted. Again, for every fission reaction 200 MeV of energy is emitted. So that way, in a very short time, large amount of energy is produced in a very short time interval in a nuclear fission reaction. Now an uncontrolled chain reaction can cause an explosion of exceptional magnitude, and that is nothing but the basis of atomic bomb. So look at this diagram. This is a simplified diagram of a chain reaction. So we have uranium 235 nucleus. It undergoes fission. It forms fission fragments. Suppose blue is barium and red one is krypton. And it emits 3 neutrons. The green one are the neutrons. And then this green one captures another uranium nucleus. This one also captures another uranium nucleus, and this neutron is also captured by another uranium nucleus. Again, fission fragments will be formed. Again, 3 neutrons are emitted. Just a second. Here also you can see 3 neutrons are emitted. Here also 3 neutrons are emitted. Here also 3 neutrons are emitted. Now these 3 neutrons will again they will be captured by another uranium 235 nucleus, and this chain of reaction will go on. So, achievement of chain reaction with uranium depends on a favorable balance among the following 4 competing processes. So, main four processes are: first, fission of uranium nuclei with the emission of more neutrons than are captured. So suppose I have a uranium 235 nucleus, it has captured one neutron, so it should not happen that only one neutron is emitted again. At least two or more neutrons should be emitted in that reaction so that the chain reaction will go on. Non-fission capture of neutrons by uranium nuclei. Sometimes what happens, uranium, it captures a neutron, but after capturing a neutron, still uranium will not undergo fission reaction, because after capturing a neutron also, it has not acquired amount of energy which is required to cross nuclear fission potential barrier. So that is how this reaction shouldn't also be there. So non-fission capture of neutron shouldn't be there. Non-fission capture of neutrons by materials other than uranium nuclei. Like what happens, we want that neutrons should be captured by uranium, but in a nuclear reactor we don't have only uranium, we have other materials as well, like moderator, structural material and all. So at times what happens, these neutrons are captured by moderator nuclei or they escape the nuclear reactor. There are so many reactions which are possible, so those reactions shouldn't also happen. The neutrons which are emitted, those should be captured by uranium itself. Escape of neutrons without being captured at all, that is what I was talking about, that the neutrons, they are not captured by either uranium, moderator or structural material, they just escape the nuclear reactor. So all these processes should not happen. So if you want a chain reaction to succeed, so it should have been realized that to sustain a chain reaction would have been an easy matter if all, so if it will become very easy that chain reaction will sustain if whatever 3 neutrons which are emitted, or approximately we talk about 2.5 neutrons are emitted, so let us consider 3. So these 3 neutrons are emitted. If all these 3 neutrons, they again participate in a nuclear fission reaction, then whatever neutrons will be produced, then again those neutrons also participate in another nuclear fission reaction, then this chain reaction will sustain. But this is not so, as neutrons are lost for the purpose of a chain reaction in many ways. The neutrons, at times they are captured by moderator material, at times they are captured by structural material, at times they are just lost. So all these are the possibilities. If the loss of neutrons by the processes 2, 3 and 4, he have mentioned these 3 processes. Non-fission capture means uranium it will capture, but it will, fission reaction won't take place. Non-fission capture by another material, escape of neutrons. If these 2, 3, 4 processes are dominant as compared to the first one, in that case chain reaction cannot be sustained. So that is all about chain reaction. So thank you so much.